In the Responsible Machine Learning book, when the authors are discussing the topic of trust and risk, they recommend us to ask a list of questions to understand what is the risk of a machine learning deployment. And one of the questions is about the quality of the model in terms of accuracy, AUC, F1, and so on. To answer those questions, we need to compare the ratio of correct predictions and incorrect predictions. But how exactly a model decides what a correct prediction is? We're going to use a digit classification model to answer that question. Before we go over the example, a disclaimer about simplifications that we're making here. There are other types of problems. For example, there are regression problems. There are other types of models. We're going to use a neural network model here, but there are other types. So the idea is to concentrate on the concepts and not so much on the actual implementation. We're going to use a neural network to do digit classification in this example. What the neural network does is it takes an image of a digit on the left side, run through the network, and on the right side we have a prediction, a class or a label for that. For example, here we have the number 2 taken from the meaningless dataset. We run through the neural network, and the neural network correctly predicts that as number 2. But what does it mean to predict a digit? In a neural network, we have many neurons in the hidden layers, and then the output of the network goes through a classification layer. In this case, it's a multi-label classification layer, and we have 10 digits. Therefore, we have 10 possible labels or 10 possible neurons at the very last layer, the classification layer. Sometimes the model is very certain about the prediction. For example, in this case, the model is 99.99% certain that this is a number 2. In other cases, like this one, this is someone else's number 2, the model still thinks this is a number 2, but is not so certain anymore that this is a number 2. So how exactly we decide what the model is going to predict? One solution is we take the largest prediction and then we call that the label. So here the largest prediction is number 2, 61.69%, and we use that and to classify this image as a number 2. However, in other cases the model is not so certain. For example, here the largest prediction is for a number 9, but the number 4 is also pretty close. So if we use the previous rule as pick the largest prediction, the model is going to say this is a number 9, but if we look at the number 4 is very close to number 9. So what should we do in a case like this? So one possible solution is we pick a threshold for the decision. Let's say, for example, that we want the model to be at least 50% certain of a prediction to make a decision. Back to our number 2. In that case, we can make a decision. But if we look again at that ambivalent number 9, in this case, it's below our 50% threshold, so therefore we cannot make a prediction. So the question is, what threshold do we pick? Is it 50%? Is it another number? So which number should we pick? Well, the answer, as many things in life, is it depends. And it depends mainly on what are the consequences of a wrong decision. Let's say, for example, that our model is being used in a check deposit application. So we run the handwritten digits in a check through the model to figure out what is the number that's on that check that's being deposited or withdrawn. In this case, we want the model to be very certain about the number. We don't want to make a mistake here. So we pick a very high threshold. So in this case, we're going to say we want to be at least 99% certain of that prediction. So that number 2 that in the previous example, we said, yeah, it's a number 2. In this case, with our higher threshold, we can no longer predict it's a number 2. We have to send that check for manual review, for example. So what happens to accuracy when we pick different thresholds? In the model that we just saw, this is what happens. If we want very high confidence level, 99.99%, the accuracy of the model is about 45%. In our check application, that means about half of the checks will be sent for manual review. The accuracy goes above 98% only if we accept a confidence level of 67% or less. So what's the takeaway from this discussion? The takeaway is that for us to use a model responsibly, we must ask questions about how its accuracy was measured and not just accept any published number. For example, if you see something that says we achieved 99.9% accuracy on some task that model was applied to, that accuracy number is meaningless until we understand the context used to measure it. For example, how were the predictions made? Is it probability based, like the examples we just saw? Is it something else? So what factors are controlling that prediction? If it's threshold based, what are the thresholds? The context for measuring the number is more important than the number itself. So if you want to experiment and see what are those effects, everything that you saw here is available in GitHub, so you can run the model on your own. There's a Jupyter notebook, and if you set that model at 50% accuracy threshold, you can see the picture here on the right, where we see all the numbers that are below that threshold and how the model is not so certain about those numbers.